Lesson 7.5, Properties of Logarithms. In this lesson, we'll use three specific properties of logarithms to help us expand and condense logarithmic expressions. The three properties of logarithms are listed below. You'll notice these properties are very similar to properties of exponents. The product property has you looking at the logarithm of a product, m times n. And notice they separate each of those terms into log base b of m plus log base b of n. The product property means you expand using addition. The second one is the quotient property, just the opposite. Product means you're dividing, product means you're multiplying, and quotient means you're dividing. In this one, you have the logarithm of a fraction. And they separate each of these terms now, log base b of m and log base b of n, using subtraction. So anytime you have a fraction or a quotient of two different parts, you split up that logarithm using subtraction. And our final property is called the power property, and this one deals with exponents. If you have the log base b of a term and that term has an exponent, what you can do is simply take that exponent and drop it out in front, and it becomes a coefficient. And that's called the power property. When working with expressions and you're asked to expand using the properties of exponents, you look at something that starts off kind of like the left-hand side of each of these equations, and you want to expand it to multiple terms like it looks like on the right-hand side. But we'll also be asked to condense, which means you'll have several logarithms that are either separated by addition or subtraction, and you'll want to condense it down to just one. So then it'll kind of look like the properties on the right-hand side, and you'll want to condense it down to look like the left-hand side when you're done. We're first going to start off with expanding down below. Our first question, expand each logarithmic expression, log base 3 of 4x. So notice we have just one logarithm, and then we have 4 times x. So this is an example of the product property. To expand, we'll split up two separate logarithm terms, one for the 4 and one for the x. And notice we separate them using addition with this property. This would split us up into log base 3 of 4 plus log base 3 of x. And if you're just expanding, the only time you'd be able to simplify or evaluate is if you could compare the 3 as your base and an answer equaling 4 in some way. Well, 3 and 4 aren't power chart friendly together, so this would be your expanded solution. We're going to change question 2 up just a little bit. Log base 7, and instead of 5, I'm going to have 49 x cubed y z squared. So you'll notice in this problem we have several parts to our product property. So we're going to start there. We also have exponents, but I'm going to split that up, or I'm going to work with that later. We have 49 x, y, and z. There are 4 different terms. That means when we expand, we're going to have 4 different logarithms. We'll start with the number first, log base 7 of 49, and then plus log base 7 of x to the third, and we just continue on, plus log base 7 of y, and then lastly plus log base 7 of z squared. So remember in that first problem when I said the 3 and the 4 weren't power chart friendly, so we left log base 3 of 4? If we look at this first term in this product, we have log base 7 of 49. That's going to be something that's power chart friendly. 7 to what power equals 49? That answer would be 2. So you can evaluate anytime you get an answer that's unit circle friendly. Also notice that x to the third power is an example of the power property. We can take that 3 as the exponent and drop it out in front of that specific logarithmic term as the coefficient. So we have 2 plus 3 log base 7 x. The y doesn't have an exponent, so we're just going to drop that term straight down, no changes. And then for that last one, z squared, it has that power property. We can take the 2 and put it as the coefficient right in front of that logarithmic term. 2 log base 7 of z. So this expanded to 4 separate terms. 3 of them still include the logarithmic term, and the first one was evaluated completely. Up next, we have log base 4 of x divided by 3y. So technically, we have a quotient and a product happening here. And I'll show you a couple of different ways this answer can be written correctly. If we separate that quotient, we would have log base 4 of x, and then minus log base 4 of 3y. Now that 3y is technically a product. But watch what happens when we split that up. We're still going to keep our log base 4 of x, but if I subtract and then make addition for the 3 and the y, I'm going to have to put that in parentheses. Log base 4 of 3, and then because this is a product property, we're just going to throw a plus right there, and then we'd have log base 4 of y. That's one way you can write it. Or you could technically distribute that negative in and have something that looks like this. Log base 4 of x would be what starts you off, minus log base 4 of 3, and then minus log base 4 of y. So both of these answers are acceptable. You can have that second answer with the parentheses, or that third answer without parentheses, but make sure you subtract both of those terms. And finally, when working with natural logarithm, that ln prefix, the same rules apply. All of the properties for log work for ln. What makes this one unique, though, is we've got the square root of x. So we need to make that an exponent. And we've done a lot of work with square roots, although I'm not trying to spell that there. There we go. Make an exponent. The square root of something is the same as that base to a specific power. Does anybody remember what that is? Remember, if the index is technically 2, this is like ln of x to the 1/2 power. That's the same as the square root. Now that's an example of the power property. And anytime we have a power property, we simply take that exponent, put it out in front, and it becomes the coefficient. And this becomes 1/2 ln x. And I like making my L like a swoopy L instead of like it looks like kind of an I. I'm fine however you write it out, as long as you know that's what it means. When asked to condense, the plan is going to be to only have one log or ln term in your final answer. So you're going to have to use those properties, but kind of backwards. So here's what I mean. An example in question 5, log base 4 of 7 plus log base 4 of 10. So this is expanded with that addition. And if we work backwards, that means it was originally a product. So this is the product property, but backwards. To condense it down to just one log base 4, we have to take the 7 and the 10 and multiply them. And once they're together in that parenthesis, we actually could just multiply them together. And when we do that, we get I don't know what happened there. We get log base 4 of 70. That's as simplified as that logarithmic term can condense to, because 4 and 70 are not power chart friendly. Let's go ahead and try the next one. Here we have 5 log x minus 4 log y. Couple of things happening here. We have coefficients out in front, and that's the opposite of the power property. So if they're coefficients out in front, and we're trying to condense this, that means they technically were exponents before. What we can do then is just rewrite this as log of x to the 5th minus log y to the 4th. And then we have that subtraction. If you look at the 3 properties, the subtraction was the expanded form for the quotient property, which means we take numerator over denominator, first term divided by second term. To condense this down to one log, remember it's not the 2 logarithms in a fraction, it's just the logarithm of a big fraction. That would be x to the 5th over y to the 4th. X and y are not like terms, therefore this logarithm is condensed completely. And we have just one more with ln. Condensing will work for ln just like it does log. So I see ln 40 plus 2 ln 2 plus ln x. The first thing I'm going to work with is that coefficient. So we're kind of using those properties in reverse order. Anytime you have that coefficient, what I'm going to do is just put that up as an exponent, and that would give us ln, let's try that again. All right, that gives us ln 40 plus ln 2 squared plus ln x. So now notice we have two addition signs here. So anytime we have addition, that was the expanded form of the product property. And that means we could actually take the 40, the 2 squared, and the x and write them as one big product, giving us just one ln. Oh, I don't know why my ln's are not working so well today. Let's try that again. We'll have one ln of 40 times 2 squared times x. Well, 2 squared is 4, and 40 times 4 is 160. We can at least simplify this a little bit to ln of 160x. And I think for this one, the parenthesis could be optional. You could actually not have it there and you'd be okay, since it's ln of that product. And those are examples of using those properties to condense expressions down to one logarithmic term. Our last helpful rule in evaluating and working with logarithms is the change of base formula. And this is useful when you have a logarithm that technically couldn't be on your calculator and we want to try to approximate its value. You can use it for log, you can even use it for ln. So here's how it works. If you have the logarithm with a base of a number and that base c doesn't equal 10, it's like some other number. What you can do is convert it to base 10 by taking the original logarithm value in the numerator and then putting whatever that base was in a new logarithm in the denominator. And so we would use base 10 so that we could plug that all into our calculator in fraction form. And this will work with log, but notice it also works with ln A over ln C. And this time you know the base would automatically be E. All right, so I'll show you what this looks like. Grab a calculator because you're going to want to enter this in. It says evaluate log base 3 of 24 using both logarithmic options. Round to 3 decimal places. Back earlier in 6.4, when we evaluated logarithms using the power chart, remember we set this equal to n and we converted to exponential. So 3 to what power equals 24? Well, there really isn't anything on the power chart that helps us here. This is why the change of base formula can help us in approximating this solution. Here's how it works. Let's rewrite log base 3 of 24 again. To convert it to a base 10 fraction, we're going to write log 24 on top divided by log 3. Now the logs don't cancel out, so you have to enter log 24 and put a parenthesis, divided by log 3, put a parenthesis, and then press enter. So please plug that into your calculator now, and let's see what you get. I got approximately 2.893. That would be my approximation for log base 3 of 24. So to check that, if you remember how we checked it before, if we type in base 3 to the 2.893 power, we do in fact get almost 24. That's our closest approximation. Now it said use both logarithmic options, so we're also going to try the ln option. Okay, so we're going to do the same thing. If we do log base 3 of 24, watch what happens when we do ln instead of log base 10. If I just type in ln 24 divided by ln of 3, since the 24 goes on the top and that base would be in the denominator, enter those into your calculator. Be careful of your parentheses. And believe it or not, you get the same thing. So you can work with either log base 10 or you can work with that ln, and they give you the same result. And that's lesson 7.5.